Welcome to Building Blocks. I'll just start with a quick introduction. My name's John Deans, and I'm a product consultant with 475 in Southern New England. Quick background on me, just that might be relevant for today's presentation, is my background is actually in building high-performance homes. So I will be talking about this largely from a point of view of how we put this type of roof system together. Looking at some case studies, and one of them is one that I actually happen to work on. So intimately familiar with it. Before I dive in completely, I just want to remind folks to read the code, know the code, talk to code experts before you, um, you know, go after a certain assembly. Make sure that it works for your climate zone, for your code enforcement, for any other conditions that you might have. I am not a code expert. I'll be referencing a couple of things from the code, but make sure that you're building according to the code, and what I'm offering here today is just some overview ideas and some ways to think about this assembly. There's a few different ways to execute it. So, to vent or not to vent? That is a question people ask all the time. And I think much like adult diapers, it depends. But what we're going to talk about today is why we're venting roofs in the first place, what exactly we're venting, and then where exactly we're putting our vent channel. So to start off with the why, this is particularly relevant in colder climates, sort of the northern half of the US and into Canada. Ice dams. Ice dams are a big issue. We have the warmth of the building bleeding out through the sheathing, warming the roof surface, allowing snow to melt and then turn to ice, and then the freeze-thaw cycle can just remind folks to go on mute if you don't mind. So then the freeze-thaw cycle can mess with your roofing and then cause leaks. So we're trying to avoid that. That's one of the problems that we're dealing with. And then the other thing is vapor management. So we want our buildings to be able to dry, and a vent channel allows us to direct where moisture goes that might be coming from inside the building, instead of condensing in places where we don't want it to, where it can cause moisture problems. So what are we venting? Specifically, we're ventilating the sheathing, we're ventilating the insulation. So the sheathing, particularly in cold climates, it cools the sheathing, and we can help avoid that ice dam effect that we were just talking about. In warmer, drier climates, it can help cool the sheathing in the summertime, which can reduce heating loads and increase roof longevity, which is pretty true for most climates. We are ventilating the insulation. So again, we're allowing that insulation to dry, so it's not accumulating moisture, particularly vapor open insulation. So we're talking about cellulose and wood fiber, rock wool, fiberglass, open cell foam. So we're allowing those vapor open insulations to dry, to ventilate, and not be trapped by the sheathing. So where are we venting? And this gets a little bit, this is like one of the small code references here. The code wants you to be venting under your sheathing, again, because we want to allow that sheathing, give that sheathing a surface to dry, and above the insulation. So you want your ventilation channel to be outside of your insulation and under your sheathing. The code basically requires an inch or more in that cavity. At 475, we recommend at least 2 inches for that vent channel. But again, reference the code in your area and build accordingly. So this assembly is maybe one of the more typical ones that we might have seen for decades now. You have your typical roof rafters, you've got your sheathing, your underlayment, your roofing, and you have that vent channel right under the sheathing, often a baffle system of some kind, allowing that ventilation channel. So the pro is this is relatively simple. In a retrofit scenario, you can insulate from the inside. You don't have to strip the roof. So it can be really great, for those assemblies from a simplicity point of view. But the cons are you're limiting your potential R value, right? We're not able to fill the whole insulation cavity. We might not have the headroom to fur those rafters down, or maybe we've got to, thicken them. So, that's one of the aspects. And we're passing air across the top of our insulation. And with fibrous insulation, we know, if things aren't packed in there totally tight and all perfect, we can get wind washing. We can get, condensation and moisture sort of building up in a process there, which from a durability standpoint might not be too much of a problem, but it's going to reduce the effectiveness of our insulation. So our favorite method is a sort of spin on this. So we've got our rafters and we've got our insulation. We're able to fill the cavity, which is great. And then we can bring a product like Mento Plus over the top of that. And that is going to give us the maximum, rafter cavity to insulate. But then it's also giving us this watertight barrier and wind-tight barrier across the top. So it's going to maximize the effectiveness of the insulation as well, inhibit wind washing or other, types of issues that we might have on that side of the insulation. So we're putting a vent channel above it before we put our structural sheathing on there. So again, that channel ideally is 2 inches and above. And what we're seeing in this diagram is you've basically got your Mento Plus, and then you've got that black strip is a double-sided tape, Tescon Nidec, that allows you to seal the fastener penetrations that are obviously going to go through the battens that create the vent channel, and then the sheathing, and then the underlayment and the roof on top of it. So the pros here are, I listed a bunch of them, but the only con is that it can be tricky. There's a couple of things that you have to be mindful of here. It's not as simple as just sort of slamming down your sheathing and moving on. So that's probably the only real drawback to this one. All right, so our first case example, and like I said, there's so much more building science information out there on venting roofs. So, definitely refer you to go out and get some more information on the deep dive, but those are the basics. So this first case study called the Timeless Barn. So this was done by a company I worked for, Emerald Builders, up in Maine. And I worked there for about 3 years. And this project was pretty unique. It was an old, probably 50s era barn that had sort of been cobbled together, kind of typical Yankee ingenuity. But because it had been around so long, the client really wanted to preserve the rafters and the old boarding and the sort of patina and the look of those exposed members. So you can see here on the right, this is sort of the finished thing. We had to build this steel catwalk with these supporting beams to basically give that roof some more structure. But then all the insulation had to take place outside of it. So, forgive me for the picture quality on this one. This was pre-COVID, so it was before we had digital cameras. We had this existing metal roof condition on the left side there. So it was basically a screwed down metal roof with strapping and an underlayment under that. And so this assembly actually was nice because it allowed us to do it in sections. So we could kind of complete a section and keep the whole thing weather tight. And so we would sort of strip a section, build our assembly, and then move on to the next section. So this is showing the backside of that board sheathing. So we stripped it down to that, and then we actually put a black underlayment. So something like Fronta Quattro, which would be UV stable, so that basically when you look up at the ceiling, you don't see anything but just dark black lines. And then over the top of that, we use IntelliX. So IntelliX is some of you may be familiar with Intello Plus. That's one of our very common products. IntelliX has the same function in the assembly when it's complete, but it has the added benefit of being exterior rated. So you can use it as your temporary weather protection during construction. And then of course you're going to bury it in insulation, and it's going to be your airtight layer and your smart vapor control for the insulation assembly. It's going to help keep moisture from migrating from the inside of the building into the roof assembly to begin with. And in this case, we put down over the walls to connect with our sheathing, which was going to be our air barrier, which we'll see in a second. So the assembly here is that IntelliX, that's all taped. And then we have 16-inch I-joists, and then the Mento Plus across the top of that, and then the battens, of course, creating the vent channel. You'll also see that if you look really closely, there are some shims under those rafters. This assembly allowed us to get a pretty flat roof over an old roof that was definitely not flat. And one of the things that we had just to pay attention to is every time we put a fastener through, we had to seal that. So something like Contiga HF, you could just squirt a little bit in there and screw through that and make sure that that IntelliX stays watertight and airtight. So this is what it looked like when that part of the assembly is done. So underneath all that, the IntelliX has a little flap that's coming down that we can't see here. The Mento Plus is coming down as well, so we can sort of encapsulate the insulation airtight on both sides. And we're totally weather tight at this point, right? So we were actually, one of the reasons we were doing this in sections, we had a lot of rain during this assembly, so we were on and off and had to tarp sections. But it meant that as we built this, we could be weather tight throughout the whole process. So this is looking at some of the details close up. So obviously we got our IntelliX, we got our I-joists, we got our Mento Plus, and our battens, and then we're flashed up to, this is going up against the dormer. So we're flashed onto the sheathing there with the Tescon Vanitape. So again, everything is properly flashed, and then we flash from the roof sheathing up onto the dormer as well. So we've got a lot of layers of protection, a lot of redundancy here, and it's a really robust assembly. In the previous picture, you could see that we left the Mento flaps down. We actually, for the insulation, this is dense pack. So you can see on the right, this is up at the peak, and we were dense packing the roof. We actually put insul web across the bottom of the joist bays, or the rafter bays, so that the insulator could just insulate from the bottom very easily, and there was a nice big evacuation area for them to do that. And then when the insulation was done, we just taped off all of the Mento Plus and closed it up. So that was kind of a nice trick in this assembly. The other thing that we did that was really helpful is, we were able to sheathe this whole thing, but this top layer where they're doing the dense packing, we just made sure to screw down so that we could back out those screws, take that piece off, they could do their dense packing, we could put it back down. And in the meantime, we had a fully sheathed roof. We also did this with the middle section of sheathing on the roof. So we nailed off the first layer, and then the second layer, we just screwed in enough to keep the sheathing on and be able to continue. Then we nailed off the next run. And the reason we did that is it allowed us, we didn't end up needing to use it for this, but it gave us the ability that if we had an issue with the dense packing and needed to, get the insulation machine in the middle of the roof, we could have. So something to think about if you're doing this assembly. We just basically left the tape off the zip sheathing, which again was fine. If there was a little bit of leaks in a rainstorm, it's just going to hit the Mento Plus and drain out. So again, we're watertight. But just one little tip is to try to give yourself some back doors. If we had had a blowout for some reason, we would have been able to actually get at it and assess the situation by pulling off that middle layer of sheathing. So that was nice. And when it was all done, we just nailed it off, taped the sheathing, and we were done. One thing that actually I skipped over that I'll go back to is you'll notice that the membrane is going vertically up the slope. The nice thing about doing this is we could stand on the old boarding, so we had nice structure to stand on, and being able to run the material all the way up the slope, and we didn't have any seams to worry about in the field. Now, with the Tescon Vanitape and proper installation, it shouldn't be a problem, but it just gave us that much more insurance to run it vertically up the slope. You don't have to do it that way, but it worked well for us. A common thing and something that we had to deal with on this was, well, we're thickening the roof by 16 inches or better. What do we do about our overhangs? So you can see here it was relatively simple. We just built overhangs down on the sawhorses, and that were nice and straight, and then we bolted them onto the side of the building. And the building walls were in and out all over the place, so we had to do some shimming, and it was fine. We could change the pitch to make sure that everything was nice and straight coming off the roof. And it allowed us to just create whatever overhang we wanted, and keep that slimmer profile that sort of fit with the original vernacular and the New England vernacular that surrounded the neighborhood. So this is the finished product. So you can see the old barn on the left there, and then what it turned into, and you can see the nice clean lines, really slim overhangs, really nice reveals. And so it's just it's a great like demonstration of the fact that we can do these high performance assemblies, we can do these thick insulation cavities, and we can still get the architectural details we want. And if that's not proof enough, clearly the architecture community and building community liked it because this project has been featured in a bunch of places: Main Home and Design, Fine Home Building. It's an example in the Pretty Good House book. If folks are familiar with that, you should be. It's great, great read. And then it even got an AIA Main Design Award. So I like this, not from, I mean, I'm very proud of it and everything, but this is less about bragging and more about the fact that, you know, we can complete really nice buildings that are super high performance and have clean architectural lines. You know, we don't have to compromise there. So the next case study is.
Before you jump on to the next one, we got a couple questions that would be
Oh,
good to
sure.
address while you're on
Yeah,
this one.
absolutely. Yeah, let's do it.
Yeah, we have one from YouTube asking if it's vented toward the dormer, wouldn't you want an exit point? Seems the flashing tape would cut off circulation.
Yeah, it's a great point. So so that was sort of more temporary weather protection. In the end, we cut it back and we connected it to the rain screen on the dormer.
And we also have Justine ask what type of siding was used on that finish photo of the timeless barn.
Yep, that's a Western cedar with a what's it called? Not a silvering stain. There's another word for it. My apologies, but it had a very light stain on it, so that's meant to silver uniformly over time. So it kind of has this sort of whitish, tannish look, and it will silver over time. But Western hemlock clapboards. So our next project is another barn. There's a theme here. This isn't only for barns and barn retrofits, but these happen to be two examples I'm familiar with, and they both take it in a different way, which is nice. So this is an old, I believe, 200-year-old barn in Newton, Massachusetts, and Auburndale Builders is doing the retrofit, and it is for the Studio for High Performance Design and Construction, which is an organization that 475 is a sponsor of, and I work with as like a guest teacher in some of their courses. But I just wanted to give them a quick shout out. It's a fantastic organization. They have a whole bunch of things that they're doing, but in general, they have this high performance building for carpenters, and so it's a 4-week program once a week where they teach carpenters who are in the field in the trades, you know, best practices for high performance construction and basic building science to help, you know, improve the skill of the labor force out there. They have been hosting BS and Beer Boston, which you can see like gets quite a crowd. So that it's this very open space in the bottom that's going to be their classroom space, and they've been really forming a hub of the building science community in the Boston area. And then they have a tech school accelerator program that's really awesome, where they're actually getting into the schools and not only training, helping to teach the students, but also teach the teachers. So this week I was actually a guest teacher at Lawrence Technical School, working with the folks who are teaching all the different trades there, because they're going to be doing a high performance project. So very awesome organization, proud supporter. But their needs for this building are very different because this bottom area is all open. The upper area is office space where the staff will be. So and they had some different design constraints as well. So this is mid demo. You can see that it's quite a lot of work. So they basically have had to preserve the exterior throughout this process, and they're going to eventually do some stuff with the exterior, but they've got to keep it as is, sort of where is, because of historical considerations and zoning, I believe. So they had to do all this work and reframing inside the building, but keep the shell intact. So it's been quite a process. They dug down, they insulated, they built a new floor system in there. So it's been quite an extensive job, and they found that they needed to put in a roof system that was going to be that was going to allow it to be a Passive House certified building. And so this is actually out of BS and Beer. They brought in Kota Ueno, who works for Building Science Corporation and has done a lot of research and looking into different roof assemblies and how a lot of how they fail, and so how to learn from that. And it was cool that one of the things that he pointed to is actually this assembly. And that's what they ended up going with. They liked that assembly because they saw the risks in some of the other ones. So they decided to go with that. And I just want to give a shout out. Code has written a ton. He's a great resource. Building Science Corporation is a great resource. And this particular presentation was a adaptation from one he gave at the NESI conference in 2020, Unvented Roofs Without Spray Foam. So I encourage folks to go find that. I think we'll have a link at the end for folks to go look through that. It's a super long presentation that they've got online for folks to give. And obviously Building Science Corp is a great company to reach out to consult on projects. Not only did they decide they needed to figure out a roof system, the roof was not in shape to sort of handle it. So instead of what we did up in Maine, they had to actually reframe the whole roof. And that gave them the opportunity to put in exactly the roof system that they wanted to do. So these are some shots of the sort of stabilization process getting there. And then obviously the new roof framing. So they were 2x12 rafters. So they've got a deeper insulation cavity. They definitely have some limits on headroom, upstairs for the office. But that was sort of step one for them. And then other than that, we're seeing the same general idea here, right? So we've got our rafters, and then we've got Mento Plus over that so that we can dense pack against it. And then those white strips that you see on top, that's Tescon Nidex. So it's a double-sided tape. You put one sticky side down, and then you can leave the release tape on until you're ready to put the framing on, which I don't recommend leaving it for a long period of time, but in a given day you can sequence it so you can lay all that out and then lay your rafters so you don't have to, so you can sort of productionize the whole process. And then they had this lower shed roof attached to the main roof that they had to create a vent channel for, which was another little tricky spot. One thing I want to highlight is you can see where the rafters on the left-hand side meet the wall. They've got a flap of Mento Plus there. So that allows them to keep their air barrier continuous through the whole assembly. So we always love to see those details. It's a technical term, floppy bits. We're a big fan of that. It's a great way to sort of detail an air barrier in a much simpler fashion. So this is taking a look at that shed roof a little bit more closely. You can see we've got our vent channel here that then has to go up and turn up the wall a little bit. So there's almost like a mini wall rain screen there, and then it gets into the roof channel. So all of that is connected in this project, which is kind of an interesting thing. And you can see the in progress shot there on the left. You've got your rim and your rafters coming into that and the Mento Plus there. So this is a closer look at that Tescon Nidex. You can see you put a nail through it and that nail is going to seal. It's going to get all gunked up with the, this is a butyl adhesive. So it's going to stick to the side of the nail as it goes in. So it's going to help keep that water and airtight under the battens. And you can see the worker on the left there is just peeling up the release strip and then sticking the batten down. And then it keeps the batten in place so you don't have them sliding off the roof and impaling someone below. So another nice little safety feature there. And then this is a look at that vent channel. So this is how they had to turn up the wall. And their battens on the roof are 2-inch. So they just rip down 2x for that. And then they're a little bit thicker on the wall. And that may have come from consulting and sort of doing some modeling to see, what they needed for maximum airflow there. So that was a cool little tricky detail. So this is just taking a little bit closer look at the Mento Plus. You can see on the underside that reinforced fiber in there. So that makes it a very strong weather barrier, but it also allows you to dense pack insulation against it. It's not going to sort of stretch greatly or risk tearing. You've got that reinforcement there. And then you can see when I got these pictures, they didn't have it yet. I think it's up now, but they're putting Mento Plus across the underside of those rafters, and then going to be filling the cavity with insulation. This is just kind of giving a sense of that space below. It's just pretty cool what they're going to be doing. This big learning lab area where they have these mock-ups that students can learn on, but they're also going to be putting a lot of modular components into place in the walls and floor and roof so they can take panels off and they can actually show the assembly. So they'll finish 95% of it, but they're going to keep sections exposed so that they can peel back the layers of the building and it can really be a learning laboratory. So yeah, so that is the Studio HPDC barn. Another take on this vented cathedral roof. So this one more using traditional framing instead of an over roof, but the same concepts. I also wanted to just go through some other details and approaches, some other ways that you can kind of do the same kind of thing here. So, we're looking at some other overhangs here. Same principle. We have that overhang built on the ground and then bolted up onto the side of the roof on the rain screen. So the rain screen is going up behind that and then coming out and can ventilate out the soffit if they're going to do it that way, or it can be connected with the roof ventilation as well. And then on the right, those battens, instead of stopping at the roof's edge and then bolting on an overhang, they just let them run long, and then they're putting 2x on the bottoms or the sides of them there to create the overhang profile so that it's all in plane with the roof. So a couple other approaches there, and you can see that they've screwed on temporary walkers so that they can go up and down the roof that way. If you really want to get wild, no sheathing. And again, this is where I often say, talk to an engineer, make sure this is okay. But in this case, we have the battens going up, and then we have 2x horizontal battens that the roofing is going to go on. And those 2x horizontal battens are helping to provide the racking strength for that roof system. So just another way to go. Again, get this stuff engineered, talk to consultants, building codes, make sure everything is appropriate for your location. But just another way you can go about it. You can skip the sheathing and then just fasten your roofing right to there, get maximum ventilation. Both of those the case studies had the membrane running up the slope. So this is a view of if you do it horizontally. So basically they're doing this in a stepwise fashion. So they're laying the membrane down and then they're putting shorter battens on there and then putting looks like horizontal 2x to basically be able to walk around on it and hold material up there and whatnot. And then doing the next layer, and then they'll tape that, do more short battens, leave them a little bit short so that you make sure you get the overlap to be able to tape that together and just work your way up the roof. I've even talked with some folks who, you do the whole thing all at once. You put the membrane down, you put the battens down, you sheathe that first layer, and you just keep staggering everything as you go up. The rolls of Mento Plus like this are 59 inches. Your sheathing is going to be 48 inches. So you can basically stagger everything pretty perfectly if you plan it all out. And that way you're always walking up the roof on sheathing. So that's another approach that you can do to approach this assembly. I wanted to make sure there was an example of that here. So you can see this person is, in this case too, instead of putting the Nidec on the Mento Plus first, they're putting it on the back of the battens and then just sticking the batten down. Either way is fine. Just trying to show some different alternatives. People always ask me, every week I'm getting questions that are, what's the best way to do this? And really it's the best way that you can execute it. Whatever you think you and your crew can, wherever you've hired can do it, work as a team and figure out what the solution is going to be, because different people work in different ways, and some people think one way is more efficient or safer or more effective, and so that just needs to be a team decision, and there's always options. I also wanted to get into some references that we have online. If you're not familiar with our Smart Enclosure series, it offers not buildable details, but generalized details for these assemblies. So different approaches for all different types of assemblies. There's a bunch in there: 2x construction, masonry retrofits, I-joist outrigger, mass timber. So we took the general assemblies that folks seem to be doing and kind of did our best work to detail those and provide some resources for folks to use. And that includes downloadable free DWG CAD files. So you can take these things and put them into your programs and mess with them, move things around, redraw sections. But it gives a template to go from, and they're not prescriptive at all, but they offer a framework to start with and a way to think about these assemblies. So please go download our Smart Enclosure ebooks. They're a great resource. And they have some 3D models in here. So looking at different assemblies, we've got like a CLT, mass timber on the left there. And then we've got sort of an I-joist and I think double stud wall combination there on the right. So kind of mixing and matching, allowing, folks to be able to kind of see what these things look like in a more three-dimensional way. So I mentioned Building Science Corporation, so definitely encourage looking at them. Just a reminder, go look up the code for your area. That's just a little screenshot of what our website looks like, and that's where to find the Smart Enclosure, where the red arrow is pointing. So good luck with your projects. Whatever region you're in, if you're looking to do assemblies like this, definitely reach out to your local 475 product consultant. So we can help you with some of these details and kind of how all these products come together. But two different approaches here and two really great roof systems that are going to stand the test of time and continue the tradition that these old buildings had. So thanks very much. Just in case anybody needed proof, that was me. It's the best picture I could find. But thanks so much for joining us on this. We love seeing you every month. We hope you come back next month for our next building blocks. And I hope you have great success with your projects going forward.